Hello everyone, this is Algo Conqueror. Today we are going to solve the problem XOR-ing the Subarrays. I personally found it very interesting. Hope you feel the same. And let's go through the question. The question basically states that we are given an array and we have to find out the subarrays of that array. You individually do an XOR operation for each subarray. You will get some result, right? For individual elements, the result is the same thing, but 3 and 4, for 3 and 4 the XOR operation gives 7. For 4 and 5 gives 1. If you do an XOR operation on 3 XOR 4 XOR 5, it will give 2. And after that you have to do an XOR operation on this result, and you have to return that result. That's what the question states. That if you please note that XOR is associative in nature. No matter for which two numbers you do first the operation, it doesn't matter. It gives the same result in whichever order you do the operation. So what can we conclude from this? So you think of this problem in a different perspective. Instead of doing XOR for each subarray, you consider them this whole thing as a single array, and you do an XOR operation for each of these elements. For 3, 4, 5 and this 3, you don't consider them as different subarrays. Consider them as a single array and do an XOR operation on that, which will give you the final result. In the question it is stated that you have to XOR the subarrays and again XOR the values thus obtained. As XOR is associative in nature, we just can consider the whole set of subarrays as a single array and do an XOR operation on that array. I hope you understood this point. And the next thing I want you to know is, so let's take an array 2, 3, 4, 5. What are the subarrays of this array? We have for an array of size n, you will have n into n plus 1 by 2 subarrays. I hope you know this thing already. So for 4 size subarray we have 10. 4 sized array we have 10 subarrays, and these are the subarrays of this array. So I told you before that the result is nothing but, if you consider this whole array as a single array and do an XOR operation on this array, you will get the result. What do I mean by XOR operation on an array? If an array consists of A1, A2, A3, so on, I mean by XOR operation that A1 XOR A2 XOR A3 and so on. I mean this when I say XOR operation on an array. So you can consider this whole subarrays as a single array and do the XOR operation on it. So now I want you to note this the crux of this problem lies in this point, that if you take 2, how many times will it be in this big array? If you take this 2, how many times will it be in this array? Think of it really carefully, because this is the crux of the problem. Let's take an array x1 x. sorry, x1, comma x2, comma x3, xi, xn. Let's take this array. If an element is xi, this xi occurs in how many subarrays? That's my question. This xi will occur in how many subarrays? Think of it. This is really important for this problem. What I am thinking is the count of this, the number of total subarrays is, as there are total n array, the total count of subarrays is n into n plus 1 by 2, right? So if you just have to find out the subarrays in which xi is a part of. So how do you find that? Can I say that if you find out the subarrays of this left subarray, the number of subarrays in left subarray, will xi be part of any of that subarray? No, right? It won't be part of any of that subarray. Similarly, if you take the right part of this right subarray, right to xi, will xi be part of any subarrays of this right part? No, right? So this is the important point. So what I'm going to do is, the number of elements to left of I is I minus 1, right? N left is equal to I minus 1, right? Is it clear? And left, right, and number of elements on the right are nr, which is n minus I. So how many subarrays can left subarray form? nl into nl plus 1 by 2, and similarly the right subarray nr into nr plus 1 by 2, which gives us I into I minus 1 into I by 2 is this, and n minus I into n minus I plus 1 by 2 is this. So these are the total subarrays, and just give me a minute. These are the total subarrays. These are the count of left subarrays in which xi is not included, and these are the count of right subarrays in which xi is not included. So how do you get the number of subarrays in which xi is included? The answer is before you. You just have to guess it. Total minus left count minus right count. This whole thing will give you the number of subarrays in which xi is present. This is the formula to find out in how many subarrays xi is present. So if you iterate through this array, let's say we are here. So how many times does 2 occur? You just use this formula and find out that count. Okay, and similarly for 3, similarly for 4, and so on. So we have found a way to create this big array. We have found out a way to create that array. How did we do that? For each element we can find out count how many times it occurs. If you find out for each element that, then you can create this array, right? Then the problem reduces to find the XOR of given array. Now that we have found out the array, we just have to perform XOR operation between its elements and return the answer. That's what's left for this problem now. Now, how do you find out the XOR of given array? Let's take these elements. I'm taking some random elements. So these could be enough. This is 10. This is what's this? This is 13, I think. 8 plus 4. 8 plus 4, 12, 13. 13. And this is 4. This is 9. Let's see how we get the XOR of an array. I took 3 elements, 10, 13 and 9, and the XOR of this is 0. No, it's not 0, I think. Yes, it's 0. And this is 1, and this is 1, and this is also 1. Did you observe anything in this? Finding the XOR of the given array. I am thinking that if the number of ones is even, then the XOR will be 0. If the number of ones is odd, then the XOR will be 1. You just try run this and you'll realize it. If you think logically also, then you'll get to the same conclusion, because if there are even number of ones, let's say there are 2 ones. What will be the XOR of this? As they are same, it will give you 0. And I'll add more 2 ones. This will give you 0. And as this is 0, now it reduces to 0, 1, 1. Now I perform XOR again. This will give me 1, and this reduces to 1, 1, and finally it will give you 0. So if the number of ones is even, and that corresponding bit will be 0. So that's how you find the XOR of the given array. You start a pointer and go towards left. For each position, you find out the number of ones at that position. If the number of ones is even, then you put a 0 there. If it is odd, then you put a 1 there. That's how you get the XOR the given array. Previously we have discussed how to create that array. Now I have explained you how to do the XOR of a given array. Now every stone is unturned for this problem. Now I have explained you each and every minute detail of this problem. Now that you know the algorithm, you just have to code it up. Let's do it now. This is the code. So I have the total count represents the total number of subarrays. Okay, that's good. And number of occurrences stores the number of occurrences, the number of subarrays in which ith element is a part of. That's what number of occurrences stores. In this loop, I am just filling the number of occurrences as I discussed in the problem. I'm writing down the formulas and finding the included in how many subarrays is the current element included. I'm finding out that, and I'm putting it in the ith position of the number of occurrences array. And this part is done. We have found out the number of occurrences of each and every element in the array. Now this part is we are for 32 bits, starting from left we are going towards right, starting from right we are going towards left, counting the number of ones. Now this, you look at this loop carefully. There are n elements, the position is I, and there are n elements, and for each element I am calculating the one count. And how do I do that? If the bit at ith position in the current element of the array is set, I am repeating it again. If the bit at current position, ith position in the current element of the array is set, then I am incrementing the one count with number of occurrences of the current element. So we are basically incrementing the one count. Now finally, what do we do? If the one count is not even, I am setting the corresponding bit in the result. If it is even, it will be anyway 0, right? So I'm doing nothing. And finally I'm returning the result. This is the code part. I hope you enjoyed the video. Please share and subscribe so that I get inspired to do these videos. Thank you very much for watching this video.